My name is Danny Rerucha, and along with my partner, Wei-Chien we developed Many Tiny Bubbles, which is a Maya plugin to create and simulate thousands and thousands of tiny bubbles. Micro-scale bubbles are an important component of realistic underwater scenes. However, existing bubble simulation techniques have severe shortcomings when trying to simulate large numbers of these microscale bubbles. Previous grid-based techniques are unable to accurately simulate the movement of a bubble that is significantly smaller than an individual voxel in the Eulerian grid. And previous particle-based techniques become computationally too expensive when tens of thousands of bubbles are introduced into the simulation. Many Tiny Bubbles addresses these shortcomings. Our implementation is built on top of a grid-based fluid solver. We achieve subgrid bubble dynamics by incorporating a random stochastic walk for each bubble that is influenced by only its neighboring bubbles, and we manage computational complexity by viewing the bubbles as a continuum rather than as the individual particles that they are. A notable feature is that any mesh in the scene can be converted into a source of bubble generation, which makes our tool very intuitive to use. Additionally, Many Tiny Bubbles supports multiple bubble emitters, as well as emitter mesh melting and custom batch rendering. Our implementation was inspired by a SIGGRAPH paper titled A Practical Simulation of Dispersed Bubble Flow. It was written in 2010 by Kim, Song, and Co. Here are the 5 major topics discussed in this paper, with the 2 primary contributions of this work highlighted in blue. The first is simulating dispersed flow as a continuum, which I mentioned improves the efficiency of the simulation by treating neighboring particles as a continuous fluid rather than as individual particles. And the second is the stochastic solver for subgrid bubble dynamics, which allows for realistic bubble movements on a scale much smaller than the resolution of the grid governing the fluid simulation. Here is the expected workflow for Many Tiny Bubbles. First, a 3D fluid container is created in the scene. Next, a mesh is converted into a bubble emitter, and that whole process happens simply by selecting the desired mesh and then clicking a single button in our menu. Now, as you scrub along the timeline, you will notice bubbles emitting from the mesh. And here we demonstrate our plugin's ability to manage multiple sources of bubble generation. Here we demonstrate a few of the many controls that we expose to the user, including mesh melting, as well as the bubble emission rate. Finally, we demonstrate how the bubbles emitted from a mesh will take on the same shader as their originating source. Here you can see some of the different simulation results that can be achieved by tuning the scattering frequency and the scattering coefficient. Here you can see the velocity field of the fluid influencing the flow of the bubbles.